A shot put of mass 6 kilograms falls to the ground from a height of 10. Here we have it, falling from a height of 10 to the ground, 10 meters. Coefficient of restitution 0. Impact is perfectly inelastic. Ball sticks to the ground. Find the speed of the ball just before impact. Okay, so we have a shot put falling. It's falling 10 meters, so we have S is equal to 10. It's released from rest. We're looking for the speed just before impact, and we know that acceleration is g. So v squared is equal to u squared plus 2as. The speed is going to be the 0 squared plus 2g by 10. So v squared is going to be equal to 20 by 9.8, which is 196. So v is going to be an even 14 meters per second. The impulse imparted to the ball. So the impulse is going to be the mass times the velocity minus the mass times the velocity before. So we have 6. So with all it stops, minus the 6. Now it's going down like this, so we're going in the minus j direction here, dealing with vectors. So minus j, well, minus 14 in the j direction. So we're going to get minus 6 by minus 14, which is 84 j in Newton seconds. My impulse. And then the loss in kinetic energy, my half mu squared. So the loss is going to be, what is it before? A half times 6 times 14 squared. Well, afterwards it's just going to give me a 0, isn't it? It's not a minus, but we take the, see what the difference is. We'll take, say, a half times 6 times 0 squared, which is just 0. So we're going to have 196 times 3, which is 600 minus 12, 588 joules. Same type of question again. You don't need to do too many of them. 0.1 is the mass dropped from rest at a height of 22.5. Coefficient of restitution 5/7. Find the speed just before impact. So rest, speed before impact. The acceleration is under gravity and the height is 22.5. V squared is equal to u squared plus 2as. V squared, you can do it really quickly. You don't have to put the 0 in. You can go straight to v is equal to the square root, but I think just take your time. 2 times a, which is g, times s, which is 22.5. So we have v squared is equal to 45 times 9.8, which is 441, and the square root of that is an even 21 meters per second. Speed just after impact, well, we have minus here, minus 21 in the j direction. So the new over the old is equal to minus e. So 7x is equal to 105. So x is equal to 15. So that's positive j. And so the impulse imparted to the ball, impulse, the mass times the velocity afterwards, mass, velocity beforehand, 0.1 times this 15 minus 0.1 times the minus 21 that we had going on before. So that's 1.5 plus 2.1, which is 3.6 Newton seconds for impulse. And the loss in kinetic energy, well, half mu squared. So before, half times, well, I'll do 1/10 to keep it as a fraction, 0.1 times the speed, which was minus 21 to beforehand, so we just put in the 21 squared, which you know is 441 divided by 20. Which is 22 and a 20, 22.05. So a half times 1/10 afterwards, we have 15 squared, which is 225/20, which is 112/10, 112, 112. So 11.25, so 22.05 minus 11.25 is going to be 10.8. 10.8 joules. In this question, the mass is 2 kg and the ball is moving velocity 5I minus 8j. This is before. It hits a smooth barrier along the y-axis, so the coefficient of restitution is 3/4. E is equal to 3/4. So the new velocity. So the new velocity over the old, this minus 8 is equal to minus e, so minus 3/4. 4x is equal to, done that the right way around, 4x is equal to 24, so x is equal to 6. So the new velocity is 5I plus 6j. The loss in kinetic energy, well, let's look at before. Kinetic energy is a half mu squared. So we have a half times 2. And we need the magnitude then of this guy. So the magnitude of 5I minus 8j is going to be equal to the square root of 25 plus 64, which is root 89. And afterwards we have the magnitude of 5I plus 6j, which is equal to the square root of 25 plus 36, which is root 61. So we have a half times 2 times root 89 to be squared before, and we have a half times 2 times root 61 to be squared afterwards. So the 2's cancel, so we just end up with 89 here, and here we just end up with 61. So 89 minus 61 is a loss of 28. Kinetic energy is measured in joules. And then the impulse imparted to the ball by the impact impulse is equal to m v minus mu. M is 2, v is this guy, 5I plus 6j minus 2 times 5I minus 8j from up above. So we're going to get 10I plus 12j minus 10I plus 16j. So the impulse imparted to the ball by the impact is equal to 28j measured in Newton seconds.